Let's talk about vertical asymptotes and holes. And your vertical asymptotes are going to be those dashed lines in the vertical direction where the graph is not going to go through. Okay. The word asymptotes comes from a Greek word, asymptotos, which means not to meet. Okay. The letter A in front of a word means that it doesn't, and symptotos means to meet. So we're looking for the zeros. In order to find the vertical asymptotes, you need to find the zeros of the function. Okay, and we've already done that. You might want to go back and look at how to find the zeros. And that's where the denominator cannot equal 0. All right, those are going to be your zeros. So in this case, you might think that -2 is a 0 and 3 is a 0, and that those would be your asymptotes. For this particular problem, we really only have one asymptote, one vertical asymptote, and there it is right there, x equals 3. And that is because this is not an asymptote, this is a hole. If you look at the original problem, if you can reduce the factor on the bottom with a factor on the top, then it's not going to give you an asymptote. Okay, let's look at this. 1 over x minus 3. So now we see that the asymptote is x equals 3. But this other one, where you would think that you would have an asymptote, is actually going to be a hole in the graph. Let me show you what the graph looks like so you can see. Okay, look at what happens down here at my graph. So you can see that there is an imaginary vertical line right here that the graph doesn't touch. So that is going to be my vertical asymptote, okay? And the line is x equals 3. And when we look back over here at -2, okay, -1, -2, look at what happens to the graph. It's like there's a big hole in it. Okay, because if you tried to plug in a -2 into the original problem, if I tried to plug it in right here and right here, I would get a 0 on the top and a 0 on the bottom. Okay, so that's why you don't have an asymptote there, you have just a hole.